Good morning, students. In the last class, we discussed about the power dissipation or power loss. So that we written as P is equals to V into I. So this loss we call as power dissipation or power loss. Also we call this one as ohmic loss, right? So one major application of this one is while we receive the power from the power station to run our household appliances. That is, for example, TVs, fridge. So ನಾವು ಯಾವುದೇ ಇನ್ಸ್ಟ್ರೂಮೆಂಟ್ಸ್ ಅಥವಾ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಡಿವೈಸಸ್ ನಾವು ರನ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ we need power. So power ಎಲ್ಲಿಂದ ಬರುತ್ತೆ ನಮಗೆ? From the power station. So power station ತುಂಬಾ ದೂರದಲ್ಲಿರುತ್ತೆ. So every city we don't have any power stations, right? So over the power stations we are getting the power to our houses or some factories or any industries, right? So over a long distance through the cables, right? So namge power station inda so power ಬೇಕಾಗುತ್ತೆ to run any household appliances. For example, if we consider any one device, either TV or fridge, so every device has its own resistance, right? So if we consider this one as one device, so this device has the resistance R. So it requires the power to run this device. So that power we write this one as P is equals to I into V. That means it requires the voltage and this device has some resistance, right? So namge power elinda bartide power station. So this power station is a hundreds of kilometers or 200s of kilometers from the city or from our household appliances, right? So while we are transferring the power from power station through the cables, so these cables having also the resistance R. That means here we have taken the resistance as RC and R is the resistance of the device, right? So the current which is flowing through the cable we taken as that one as I, right? So we know power P is equals to V into I, or in terms we can write that is power which is supplied from the power station, right? That one we taken as PC through the transmission cables, right? So PC is equals to I square RC, right? So where RC is the resistance of the cable, right? So here we need the device to run, means here we need the current I, that is we can write the current I is equals to P divided by V. So substituting here PC is equals to P divided by V whole square into RC, right? So PC is equals to P square RC divided by V square, right? So here now ಯಾವುದೇ ಒಂದು ಡಿವೈಸ್ ನ ರನ್ ಮಾಡ್ತಿದ್ವಿ, it needs fixed power, right? So some 200 watts means that device requires only the 200 watts. So now extra ಕೊಟ್ಟರೆ ತಗೊಂತಾ ಇರೋದು ಎಷ್ಟು watts ಇರುತ್ತೆ? 200. So that means this power required by the device is constant, and also the resistance of the device or the resistance of the transmission cable is also the constant. So that means we can write power transmission from the power station is inversely proportional to the square of the voltage which is required by the device, right? So now we baribodu PC, that is power which is supplied from the power station is inversely proportional to the square of the voltage. That means voltage ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋದಂಗೆಲ್ಲ power loss ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ ನಮಗೆ ಕಮ್ಮಿ ಆಗುತ್ತೆ. So the main purpose here is to reduce the power loss while transmission. So now ಇಲ್ಲಿಂದ some several 100 kilometers ವರೆಗೂ ನಾವು ಪವರ್ ಸಪ್ಲೈ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಸೊ ಅಲ್ಲಿ ನಮಗೆ ಲಾಸಸ್ ಜಾಸ್ತಿ ಆಗ್ತಿರುತ್ತೆ. ಆ ಲಾಸಸ್ ನ ಕಡಿಮೆ ಮಾಡಬೇಕು ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಏನು ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ ನಾವು? the relation, the method that is which is inversely proportional to V square. So now V value na ಜಾಸ್ತಿ ಮಾಡ್ತಾ ಹೋದಂಗೆಲ್ಲ that means the voltage which we are supplying through this transmission cable is more, then the reduce of the power in the transmission cable is less, right? So the first condition is for transmission the power over the transmission cable we need more voltage. That means we are supplying with high voltage or with less current, right? So because by this relation, so resistance of the transmission cable is constant, right? So we can write P is directly proportional to I square. So now ಎಷ್ಟು ಕಡಿಮೆ ಕರೆಂಟ್ ನ ಸಪ್ಲೈ ಮಾಡ್ತಿದೀವೋ so ನಮಗೆ ಅಷ್ಟು ಕಡಿಮೆ ಪವರ್ ಲಾಸ್ ಆಗುತ್ತೆ. ಸೊ ನಾವು ಎಷ್ಟು ವೋಲ್ಟೇಜ್ ನ ಸಪ್ಲೈ ಮಾಡ್ತೀವೋ ಜಾಸ್ತಿ ವೋಲ್ಟೇಜ್ ಸಪ್ಲೈ ಮಾಡೋಷ್ಟು ಕೂಡ ಪವರ್ ಲಾಸ್ ಆಗುತ್ತೆ, ಬಿಕಾಸ್ ಇಟ್ ಈಸ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಟು ದ voltage, right? So by these two conditions, or by high voltage, right? So ನಮಗೆ ಡೈರೆಕ್ಟ್ ಪವರ್ ಸ್ಟೇಷನ್ ಇಂದ ಡೈರೆಕ್ಟ್ ನಮ್ಮ ಹೋಮ್ ಗೆ ಯಾವುದೇ ತರದ್ದು ಲೈನ್ಸ್ ನ ನಾವು ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಲೈನ್ಸ್ ನ ಹಾಕೊಂಡಿರಲ್ಲ, ರೈಟ್? ಸೊ ಇನ್ ಬಿಟ್ವೀನ್ ವಿ ಹ್ಯಾವ್ ಒನ್ ಡಿವೈಸ್, ಸೊ ದಟ್ ಒನ್ ಇಸ್ ದಿ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್. ಸೊ ಫಸ್ಟ್ ಪವರ್ ಸ್ಟೇಷನ್ ಇಂದ ಎಲ್ಲಿಗೆ ಬರುತ್ತೆ? ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್. ಸೊ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಮೇನ್ ರೀಸನ್ help ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ in between the power station and to the household appliances, means it converts high voltage to the reasonable voltage. So now high voltage ಅಲ್ಲಿ ಪವರ್ ನ ಸಪ್ಲೈ ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ ಈ transformer receives the high voltage, so this high voltage will convert it to the low voltage. So ನಮಗೆ household appliances ಗೆ we clearly requires 220 volt, but here we are getting some 10,000 to 20,000 volts to the transformer, right? So hence ನಮಗೆ ಇಲ್ಲಿ ಏನಿರುತ್ತೆ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ಹತ್ರ ಡೇಂಜರ್ ಸಿಗ್ನಲ್ ಕೂಡ ಹಾಕಿರ್ತಾರೆ. So no one can go near to that of the transformer because it has a high voltage, right? So this is about the power loss, right? So main important is PC is directly proportional to I square and PC is inversely proportional to V square. So ಈ ಎರಡರದ್ದು ಮೀನಿಂಗ್ ಏನು ಅಂದ್ರೆ ಎಷ್ಟು ಕಡಿಮೆ ನಾವು ಕರೆಂಟ್ ಸಪ್ಲೈ ಮಾಡ್ತೀವೋ ಅಷ್ಟು ಕಡಿಮೆ ಪವರ್ ಲಾಸ್ ಆಗುತ್ತೆ, ಅಥವಾ ಎಷ್ಟು ಜಾಸ್ತಿ ವೋಲ್ಟೇಜ್ ಅಲ್ಲಿ ನಾವು ಸಪ್ಲೈ ಮಾಡ್ತೀವೋ ಅಷ್ಟು ಕಡಿಮೆ ಪವರ್ ಲಾಸ್ ಆಗುತ್ತೆ, ರೈಟ್? ಸೊ ಇವೆರಡು ನೆನಪಲ್ಲಿರಬೇಕು. So this is about the power and electric energy, right? So next, combination of resistance. So combination of capacitors in the previous chapter we discussed, right? So same here also. Combination of resistance or resistor. So resistors andre devices, so resistance andre it is a property. So here also we have two combinations. So one is series. So very important for 5 marks derivation kelidare, right? So similarly capacitors alli ಏನು ಸ್ಟಡಿ ಮಾಡಿದ್ವೋ ಇಲ್ಲಿ ಕೂಡ same procedure and same method. So next one is parallel combination, right? So resistance we denoted by the symbol like this. So this is what the symbol of the resistance and it is denoted by R, right? So series combination andre if we want to join two or more resistors in series, that means only one end of the resistance is connected to the another end of the resistance, right? So idu one resistance, so this is the another resistance, right? So we want to join these two in series, means only one end of the resistor is connected to the another end of the another resistor. So that means another two ends will left as it is, right? So if we want one more resistance to join into this, means again by connecting one end of the third resistor is connected with the another end of the second resistor, right? So this gives what the combination of the resistance which are in series. So next, parallel combination. So we have two or more resistance which we want to join in parallel, right? So here one end of all the resistors are joining together. So ella resistors do one side end by joining together all the three ends. So in the simultaneously other ends also joining madidre namage these resistance we get the parallel combination, right? So series andre only one end we are connecting with the another resistor. So parallel andre all the three resistors one end is connected one point and another end is connected with another point. So here we get the resistance which are in R1, R2, R3 andre three different types of resistors which are connected along series and across parallel, right? So first series combination. Right. So consider two resistors having the resistance R1 and the another resistance having the resistance R2, which are connected in series. Now apply the potential across these two resistors are flowing per unit time. So R1 resistance ಅಲ್ಲಿ ಎಷ್ಟು electrons flow ಆಗ್ತಾ ಇರುತ್ತೋ same number of R2 only flow ಆಗುತ್ತೆ because there is no any deviation. So R1 flow ಆದ್ಮೇಲೆ next R2 ಬರುತ್ತೆ. So that means current is same in both R1 and R2, right? So as the resistance are different, R1 ಮತ್ತೆ R2 resistance different ಆಗಿರೋದ್ರಿಂದ voltage ಏನಾಗುತ್ತೆ ನಮಗೆ ಇಲ್ಲಿ change ಆಗುತ್ತೆ. So V1 is the voltage across the resistance R1, that is from the Ohms law. V is equals to IR. So I is constant, R value is changing, right? So for example, R1 value has some 10 ohm, current I is constant, that is some 2 ampere. So we get the voltage across R1 is R into I, that is 20 volt, right? So the same current which is flowing across R2. So in the second case, some R2 is 15 ohm, the current is same, that is 2 ampere. So the voltage is 2 into 15, 30 volt. So we are getting the two different voltages. So that's why we are taken V1 and V2. So V1 is the voltage which is across the resistance R1 and V2 is the voltage across the resistance R2. So these two voltages is equals to sum of the voltages V1 plus V2. Right? So that one is, we call that one as the first relation, right? So from Ohm's law, right? So V is equals to I R, right? So here the resistance is R1, right? So we get V1 is equals to I R1, the voltage across the resistance R1, right? So similarly V2 is equals to I R2. Now substitute V1 and V2 in the first equation, right? So V is equals to I R1 plus I R2. So in these two we have the common current, right? So V is equals to I into R1 plus R2, right? So calling this one as second equation, right? So now comparing this with the equivalent resistance. So what is equivalent resistance means? One resistance which has the ability to do the combination of these two resistance. So ಯಾವುದೋ resistance ಇದೆ, ಆ resistance ಈ ಎರಡು resistance ಗೆ equal ಆಗಿರುತ್ತೆ. So ಅಂತ resistance ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ? Equivalent resistance, right? So ಇದು series ಇರೋದ್ರಿಂದ we take an equivalent resistance as RS. So same potential is applied across the equivalent resistance RS and I is the current which is flowing across the resistance RS. So again here from Ohm's law, we write V is equals to I RS, right? So ಈ ಎರಡು resistance ಏನು same resistance equivalent resistance ಮಾಡುತ್ತೆ. So ಅದಕ್ಕೆ ಈ ಸರ್ಕ್ಯೂಟ್ ಇದಕ್ಕೆ ಈಕ್ವಲ್ ಆಗಿ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಿದೀವಿ. So same potential ಎರಡು ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲೂ same current is flowing, right? So calling this one as equation 3, right? So same potential apply ಮಾಡಿರೋದ್ರಿಂದ from equation 2 and 3, right? So ಎರಡು ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲೂ same potential ಇರೋದ್ರಿಂದ equation 2 ಮತ್ತೆ equation 3 ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ LHS ಏನಿದೆ ಎರಡರಲ್ಲೂ ನಮಗೆ ಸೇಮ್. So both having the same LHS, hence we can equate the RHS. So IRS is equals to I into R1 plus R2. So ಎರಡರಲ್ಲೂ current same flow ಆಗ್ತಿರೋದ್ರಿಂದ equivalent resistance which is in series RS is equals to R1 plus R2. So this is what the equivalent resistance which are connected in series, right? So very important. So 5 marks get ರಿಪೀಟ್ ಆಗ್ತಾ ಇದೆ ರೈಟ್ ಸೊ ಬಟ್ ಇದ್ರ ಜೊತೆ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಕೂಡ ಬರೀಬೇಕಾಗುತ್ತೆ ಸೊ ದಟ್ ಈಸ್ ಕನ್ಸಿಡರ್ಡ್ ಟೂ ರೆಸಿಸ್ಟೆನ್ಸ್ ಆಫ್ ರೆಸಿಸ್ಟೆನ್ಸ್ R1 and R2 connected across the common potential V and I is the current flowing in the circuit. So that is equivalent to the equivalent resistance having the resistance RS and the same potential V and current I. So followed by these mathematical steps, right? So simple is that R4 B. So ಇಲ್ಲಿ ಕೂಡ ನಮಗೆ ಫ್ಲೋ ಆಗ್ತಿರೋ ಕರೆಂಟ್ ಏನಿರುತ್ತೆ resistance RS that is equals to R1 plus R2 plus R3 and so on up to RN. Specific resistance ಕೊಟ್ಟಿರಬಹುದು but in series ಅಲ್ಲಿ ಇದ್ರೆ all the resistance will adds up, that is R1 plus R2. For example, if R1 is some 2 ohm, R2 is some 5 ohm, R3 is some 10 ohm. So next R4 some 5 ohm. So then equivalent resistance of these combination we get RS that is equals to 2 plus 5 plus 10 plus 5, right? So we get 22 ohm. So just algebraic add agutte when all the resistance are connected in series, right? So next, if all the resistance having the same resistance, that means R1 is equals to R2 is equals to R3 up to Rn, we have the common resistance R, right? So directly we can write Rs is equals to N into R, where N is the number of resistance, right? So that means R1 value 2 ohm is andre R2 value kuda 2 ohm, R3 kuda 2 ohm and R4 kuda 2 ohm, right? So all the resistance having the same resistance, so we can directly write the equivalent resistance Rs is equals to N into R. So here we have the 4 resistance, so 4 into 2 we get 8 ohms, or we can add 2 plus 2 plus 2 plus 2, so then also we get the same, right? So adukoskara idu shorter formula Rs is equals to N into R. So idu namage competitive agi help agutte, right? So this is about the series combination, right? So next, parallel. So parallel, considering same two resistance R1 and R2, right? So considering two resistance, one is R1 and another is R2, which is connected across the common potential V, right? So current flowing in this circuit we taken as I, right? So here at this junction, so current that means, as already said, I is equals to Q divided by T. So current flow ಆಗ್ತಿದೆ ಅಂದ್ರೆ charges ಕೂಡ flow ಆಗ್ತಾ ಇದೆ. So at this junction the charges are gets divided. That means some amount of the charges will flow on R1 and some amount of charges will flow on R2. So that means charges ಏನಾಗ್ತಿದೆ equal proportionally R1 ಮತ್ತೆ R2 ಅಲ್ಲಿ ಹೋಗ್ತಾ ಇಲ್ಲ. Only some amount of charges is flowing on R1. That means the current flowing through R1 is I1. Next, some amount of charges is flowing through R2, so hence we get the current I2, right? So again it will travel up to here, then again combine I1 plus I2, we get the total current I, right? So from this we can write I is equals to I1 plus I2, calling as equation 1, right? So again from Ohms law V is equals to IR. So in parallel combination, the potential always same across all the resistors because current divides, right? So for that reason, the potential across all the resistors are same in parallel combination. ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. ಬಹಳ ಕಡೆ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಬೇಕಾದ್ರೆ ಇದು ಮೇನ್ ಫ್ಯಾಕ್ಟರ್ ಆಗಿ ವರ್ಕ್ ಮಾಡುತ್ತೆ. ಸೊ ಪ್ಯಾರಲಲ್ ಅಲ್ಲಿ ಯಾವುದೇ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇತ್ತು ಅದ್ರ ಅಕ್ರಾಸ್ ಅಲ್ಲಿ ನಾವು ವೋಲ್ಟೇಜ್ ಅಪ್ಲೈ ಮಾಡ್ತಿದ್ವಿ ಅಂದ್ರೆ ಎಲ್ಲಾ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಕೂಡ ನಮಗೆ ವೋಲ್ಟೇಜ್ ಏನಿರುತ್ತೆ ಸೇಮ್ ಇರುತ್ತೆ, ರೈಟ್? So from this we can write current I1 is equals to V divided by R1. That is current which is flowing across R1. I1 is equals to V by R1. So V is same for all the two resistors, right? So next I2 is equals to V divided by R2. Now substitute the values of current I1 and I2 to the I, right? So I is equals to V by R1 plus V by R2. So I is equals to V taken common 1 divided by R1 plus 1 divided by R2. So calling this one as equation 2. So now again this circuit is equivalent to the equivalent resistance, right? So here we are connected in parallel, hence we taken RP. So that means the resistance which are connected in parallel, right? So we need current I flowing in the circuit, that is I is equals to V divided by RP. So calling this one as equation 3. So ಇಲ್ಲಿ ಎಷ್ಟು ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಾ ಇದೆ ಈ ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಕೂಡ ಸೇಮ್ ಅಮೌಂಟ್ ಆಫ್ ಕರೆಂಟ್ ಇಸ್ ಫ್ಲೋಯಿಂಗ್ because we are applying the same potential V, right? So again comparing equation 2 and equation 3. So current in both the circuits are same. So LHS same ಇರೋದ್ರಿಂದ RHS ಕೂಡ ಏನಾಗುತ್ತೆ ನಮಗೆ ಈಕ್ವಲ್ ಆಗುತ್ತೆ. That is V divided by RP, that is equals to V into 1 by R1 plus 1 by R2, right? So voltage get cancels, we get the final relation 1 by Rp is equals to 1 by R1 plus 1 by R2. Or we can write this one Rp is equals to, by taking LCM R1 and R2, so we get R1 R2 divided by R1 plus R2. This is when two resistors which are connected in parallel, right? So same, when more number of the resistors which are connected in parallel, so V, R1, R2, R3, R4, right? So the equivalent resistance 1 divided by Rp is equals to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 and so on up to 1 by Rn. So now ಎಷ್ಟು number of resistors connect ಮಾಡಿರ್ತೀವೋ ಅಷ್ಟು that is inversely proportional ಅಲ್ಲಿ ಇರುತ್ತೆ 1 by Rp. So don't directly write Rp is equals to 1 by R1 plus 1 by R2, right? So if all the resistance are equal, R1 is equals to R2 is equals to R3, R4, so that is equals to R. So ella resistance kuda same values ittu andre the equivalent resistance 1 by Rp, that is equals to N divided by R. So from this Rp we can write R divided by N. So where N is the number of resistor or resistance. So devices irbodu athwa directly resistance irbodu, right? So namge example kelidre up to this we need to derive. So important, very simple, right? So 5 marks get either in capacitors alladu keltare or in resistance alladu keltare. So erdu method same ide, but don't confuse with series and parallel. Erdu opposite ide. So ನಮಗೆ ಪ್ಯಾರಲಲ್ ಕಾಂಬಿನೇಷನ್ ಅಲ್ಲಿ 1 by Rp ಇತ್ತು ಅಂದ್ರೆ ಈ ಕೆಪಾಸಿಟರ್ ಅಲ್ಲಿ ಸೀರೀಸ್ ಅಲ್ಲಿ 1 by Cs is equals to 1 by C1 plus 1 by C2. So ರೆಸಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ಬಂದಿರೋ ಈಕ್ವೇಷನ್ ಕೆಪಾಸಿಟರ್ಸ್ ಅಲ್ಲಿ ಇಂಟರ್ಚೇಂಜ್ ಆಗುತ್ತೆ. So don't confuse between the capacitors and resistance, right? So this is about the combination of the resistance, right? So series ಮತ್ತೆ resistance ಅಲ್ಲಿ combination ಅಲ್ಲಿ ನೆನಪಿಟ್ಕೋಬೇಕಾಗೋದು in parallel voltage remains same, in series current remains same. So series ಅಲ್ಲಿ voltage divides, in parallel ಅಲ್ಲಿ current divides, right? So ಎರಡು ಫಾರ್ಮುಲಾ ನೆನಪಿಟ್ಕೊಂಡ್ರೆ easily you can derive the relation. So next topic is cells, EMF and internal resistance. So almost ನೀವು ಇದನ್ನ chemistry study ಮಾಡಿರ್ತೀರಾ, cells and EMF. So EMF means electromotive force. So cell is electrolytic cell, right? So what is electrolytic cell? So it is a simple device which maintains the steady current in an electric circuit. So that one we call as the electrolytic cell, right? So if we define the electrolytic cell, or simply if we say what is cell means, it is a simple device which maintains steady current in an electric circuit, right? So steady current, in the first class only we discussed. So current ali variable current ಮತ್ತೆ steady current irutte. So steady current means always we are not getting the steady current, right? So steady current means same number of the charges which are flowing across the cross sectional area, right? So if we take any one conductor, right? So this conductor consists of charges. So in metals if we consider the electrons which are present in the conductor, right? So these electrons are flowing across the cross sectional area in the conductor. So initially some 10 electrons are flowing across this cross section area in 2 seconds. So then next in every 2 seconds the same amount of the electrons are crossing this cross section area. So aduna ನಾವು ಏನಂತ ಕರೀತೀವಿ, steady current, right? So I is equals to same Q divided by T. So the number of charges flowing across the cross section area per unit time, right? So here we have 10 electrons, that is 10 divided by 2, that is, sorry, this 10 electrons is 10 into 1.6 into 10 to the power of minus 19, because Q is equals to N into E, where N is the number of electrons and E is the charge of the electron. So this much of the amount of current which is flowing in the conductor, right? So but namge every time same 10 electrons in 2 seconds iralla. Sometimes it may be 50 electrons in 2 seconds or 60 electrons. That means the flow of electrons are varying inside the conductor. So anta current ನಾವು ಏನಂತ ಕರೀತೀವಿ, variable current. So in electrolytic cell ಅಲ್ಲಿ always it makes the steady flow of the charges. So ಅದಕ್ಕೆ ಇದನ್ನ electrolytic cell. So it maintains the steady current in an electric circuit, right? So cell, it consists of 2 electrodes, right? So it consists of 2 electrodes. So one is taken as positive electrode and the another one is taken as negative electrode, right? So defining P for positive electrode and N for negative electrode. So these 2 electrodes are immersed in an electrolytic liquid. So this is the solution. So electrolytic solution is nothing but we call this one as the liquid conductor, right? So electrolyte or electrolytic solution means this acts as a liquid conductor. Solutions means fluids, right? So act that one as the liquid conductors, right? So P is the positive electrode and N is the negative electrode, and this is also the conductor, right? So here this positive electrode or P electrode having the positive potential, right? So we take a potential across the positive electrode, that is equals to V plus, right? So here V is the potential across the electrode with the electrolytic solution, right? So here comparing this electrode, the potential which is difference, potential means potential difference between the electrode and to that of the electrolytic solution. We call that one as the potential across P. So we taken that one as V plus. So in the same wise, N is the negative potential, right? So the potential difference between the negative electrode and to that of the electrolytic solution, right? Potential difference of potential across the negative electrode. So that is equals to minus V minus. So negative represents what? The negative charges which are present in this electrode. The potential difference between the electrode and to that of the electrolytic solution. So that one we call as the potential difference, right? So ಇಲ್ಲಿ potential difference ಅಂತ ನಾವು ಬರೆಯಬಹುದು ಅಥವಾ potential across P and potential across N, or potential difference between P and to that of the electrolytic solution, potential difference between the negative electrode and to that of the electrolytic solution. So directly we can write the potential, right? So now when there is no flow of current in between P and N, right? So the potential difference between P and N electrons, right? So ಇಲ್ಲಿ ಬರ್ಕೊಂಡಿರೋದು ಯಾವುದು? Potential difference between P and electrolytic solution, N and electrolytic solution. Now we are finding the potential difference between P and N when there is no current in the circuit, right? So the potential difference between P and N, that is equals to V plus minus of minus V, right? So the potential difference between these two electrodes, because when there is no supply of current, the potential in the electrolytic solution at every point remains same, right? So if you take this point as A and this point as B, right? So the potential at A, that is equals to potential at B when there is no current, right? So ಇಲ್ಲಿ ನಾವು potential positive electrode between P and solution ಏನು ಬರ್ಕೋಬಹುದು? Vp minus Va, that is the potential difference between electrode and to that of the electrolytic solution, right? So and Vn minus Vb, right? So this is the potential difference between electrode and to that of the solution, potential difference between the negative electrode and to that of the solution. So when there is no current, Va is equals to Vb. That means the potential difference Va minus Vb is equals to 0, right? So hence we are directly writing the potential V plus minus of V minus, right? So iduna ಬರ್ಕೊಳ್ಳೋ necessity ಇಲ್ಲ, because when there is no current, potential in electrolytic solution remains constant, right? So here we taken 2 points, so that's why Va is equals to Vb, right? So hence the potential difference between P and A and N and B, we can write that one as V plus minus of V minus, right? So this is equals to V plus of V minus, right? So this potential difference we call as electromotive force. So simply we call that one as EMF, that is equals to V plus plus of V minus. So this is when there is no current in an electrolytic solution, right? So the symbol for the electromotive force is E or epsilon. So we denote this one with the epsilon or E, right? So E is equals to V plus of V minus. This is when there is no current in the electrolytic solution, right? So ಇದನ್ನ first case ಅಂತ ನಾವು study ಮಾಡಬಹುದು, right? So next, in the second case, consider one conductor which having the resistance R and it is connected to the electrodes P and L, right? So calling here these points are C and D, right? So the now current flowing in this direction, right? So in the second case, up to here we studied when there is no external circuit, means when there is no current, right? So we getting the EMF E is equals to V plus V minus, that is potential on the positive electrode and to that of the potential on the negative electrode, right? So now in the second case, consider one conductor which having the resistance and it is connected to the two electrodes, right? So from Ohms law, again from the Ohms law, V is equals to I into R. So I is equals to V divided by R, right? So here again by studying this case, right? So here when the resistance is infinity. So here also we discussed with the cases. So in the first case, when resistance is equals to infinity, then current which is flowing in the external circuit, I is equals to V divided by circuit, I is equals to V divided by infinity. So anything by the infinity is 0, right? So the current flowing in the infinity. So anything by the infinity is 0, right? So the current flowing in the external circuit is 0, right? So 0, right? So what it says means V is the potential difference between right? So R infinity and we are not connecting any resistance across this, right? So R infinity and we are not connecting any resistance across this electrodes, right? So ಇಲ್ಲಿ ನಮಗೆ ಯಾವುದೇ ತರದ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇಲ್ವಾ ಅಥವಾ ಹೈ ರೆಸಿಸ್ಟೆನ್ಸ್. So ಇಲ್ಲಿ ನಮಗೆ ಯಾವುದೇ ತರದ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇಲ್ವಾ ಅಥವಾ ಹೈ ರೆಸಿಸ್ಟೆನ್ಸ್, that value is approximately equals to infinity, means there is no flow of current in the external circuit, right? So where V is the potential difference between P and L, right? So this potential difference, we write V is equals to potential difference between P and A plus potential difference between A and B plus potential difference between B and N, right? So this we can write V is equals to V plus V minus, so that is equals to En. So again we getting the same relation. So that means V is equals to E, right? So voltage, applied voltage, that is equals to the EMF. So when an external conductor is connected across P and N. So when an external conductor is connected across P and N. So next, in second case, when R has some value, that means some finite value, we have the R, right? So the current, that means some finite value, we have the R, right? So the current flowing across this resistance is from C to D, right? So next here, this current we call that one as the steady current, right? So this current across this resistance is the steady current that is flowing across this resistance from C to D, right? So again from C to D, right? So again the current which is flowing, the current which is flowing from P to C, C to D, D to N. Again, the electrolytic solution, we call that one as the liquid conductor. So here the current is flowing from B to A, right? So the current is flowing inside the electrolytic solution, that is from N to P, right? So in the external circuit, the current is flowing from P to N, and inside the electrolytic solution, the current which is flowing from N to P. That means opposite, right? So now, if we find the potential difference which is applied across the P N, so we can write from the same relation V, that is equals to first one, the potential difference between P and A, right? For that we can write V plus, right? So as the current is flowing from B to A, so here we have the, so in this case, in the second case, VA is not equals to VB, right? Because the current is flowing, the negative sign, because it is opposite to the direction of flow of current, right? So in the external circuit it is flowing from P to N, but in the electrolytic solution it is from N to P. That means opposite to that of the external circuit current, hence we are taken minus, right? So plus, and the last one is potential difference between V and N. We taken that one as V minus, right? So we can write V is equals to V plus V minus minus IR. So V plus V minus, we can replace this one with the EMF. That is V is equals to E minus, right? So if the internal resistance of the electrolytic solution is very less, that means the R value is approximately equals to 0, then the potential of resistance R is equals to the potential across the P and N electrodes, right? So if R is very less, then we write V is equals to E, right? So next, again from the Ohm's law, the potential across this resistance we taken as V is equals to IR. So same potential is in between the potential P and N, right? So from Ohm's law, V is equals to IR. Calling this one as equation 2 and here this one as equation 1. So in both the cases, the LHS we have the same potential. That's why we can equate the RHS. IR is equals to E minus IR. So from this we can take I common, R plus R, that is equals to E, and I is equals to small r. So this gives the final expression for the current which is flowing in an external circuit which having the internal resistance R. Right? So if, as I mentioned here, if R is very less, that means the internal resistance R is equals to 0, we are getting the maximum current in the external circuit. So that we can write I max is equals to E divided by . So this is about the cells, EMF and internal resistance, right? So two important relation is I is equals to E epsilon divided by R plus R, where R is the resistance which is connected external to the circuit and small r is the internal resistance of the cell. So overall this one we call as cell, right? So in the normal we are mentioning voltage like this, one line and long and another one is very small, right? So long line we taken as positive and the short one we taken as negative. So this indicates what? The voltage only. So EMF is also denoted by the same, right? So along with this E R, where E gives what? EMF of the cell and R gives what? The internal resistance of the cell, right? So while doing problems, we need to notice this small r. So now this small r ಕೊಟ್ಟಿದ್ದಾರೆ ಅಥವಾ ಇಲ್ವಾ ಅನ್ನೋದನ್ನ ಚೆಕ್ ಮಾಡ್ಕೋಬೇಕು. Because in the problems they mention only 15 volt, some 5 ohm. So if they mention like this means this gives what the EMF and 5 ohms gives what the internal resistance of the EMF. So in this case they mention only some 15 volt. So ಇಲ್ಲಿ ನಮಗೆ ಯಾವುದೇ ತರದ ರೆಸಿಸ್ಟೆನ್ಸ್ ಮೆನ್ಷನ್ ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ ಈ ಇಂಟರ್ನಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಏನಿರುತ್ತೆ ಆಲ್ವೇಸ್ 0, right? So important. So the first relation and this one is the final relation. These two are very important, right? So in the next we will discuss with the combination of cells, right? Then so another doubt.